Hi, this is Mrs. Rodriguez with Box and Whisker Plots lesson video. All right, let's first start with the warm-up. So these dot plots show the amount of time spent online between two different groups of students. Let's see. So group A is the number of minutes online for group A, okay, and then we have group B. How much greater is the mean of time spent by group B than the mean amount of online time spent by group A? Round your answer to the nearest hundredth. Okay, so we have our data. They want to know the difference between the mean, right? How much greater? So we need to find the mean of group A and the mean of group B, and we have to round to the nearest hundredths and take the difference. Now each dot in these graphs represent one data point. So if I was going to figure out the mean of group A, so here's my group A, right? The mean, remember, you have to add all the data points and divide by however many data points you added. So mean. Step 1, add all the numbers, and then your step 2 is divide by number of by, let me write this a different way, how many numbers you added. Okay, so for group A, they had 220s, so 20 plus 20 is 40, right? So I'm going to add 40. This is 40. 40 times 4 is going to give me 160. 60 and 2 times is going to be 120. We have 80 once, and then we have 103 times, so that's 300. So I'm just going to add up these numbers. So 40 plus 160 plus 120 plus 80 plus 300. Okay? And if you add them all up, you get 700. Now, how many numbers did we add up? Well, we added up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're going to divide by 12. And your answer, when you divide by 12, should be 58.3. And the 3's are going to keep going, so I'm actually going to put a bar over it. Now it's important to note that it says round to the nearest hundredth. So if this is going to have a 3 next to it, that means you're going to round down, and your final answer for A is going to be 58.33. Right? Okay, so moving on to the next one. Let's choose a different color. Let's do blue. So for group B, we have 0, 2 20s, which makes it 40, 2 60s, which make it 120. 80 times 3 is going to be 240, and then 100 times 1, 2, 3, 4 is going to be 400. So I'm going to go ahead and add those data points. So I have 0 plus 40 plus 120 plus 240 plus 400. And when you add them all up, you should get 800. We need to count the data points, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 again. I'm going to go ahead and divide by 12, and you should get 66.6 this time with a bar over it. Once again, that means this is going to keep having 6's, right? So 6 is greater than 5, so when we have to round to the nearest hundredth, we're going to round up. And your final answer for group B should be 66.67. Okay? 66.67. Now, they want to know how much greater is B than A. So we need to subtract them. So we have 66.67. We're going to take away group A to see how much bigger group B is. No, that's not what I wanted. And when we subtract them, 7 minus 3 is 4, 6 minus 3 is 3. We're going to have to borrow and we get 8.34. And that is our final answer, 8.34. So the biggest thing to remember is each dot shows how many times that number has taken place. So if I have in group A 2 dots for 20, that means we got 2 20s. And I just added them together and got 40. Okay, so these are dot plots, and yeah. Okay, so moving on. Box and whisker plots. Box plots, okay, so a box plot displays data distribution by using 5 key numbers, okay? The difference between the first and third quartile is called the interquartile range, okay? And that's the difference between the first and the third. So that means we use Q3 and Q1 to represent the first and third quartile, right? Q3 would be the third quartile, Q1 would be the first quartile. So here's our 5 data points. The smallest piece of data is called the minimum. Okay. The median of the lower half of the data is your first quartile. Which is our Q1, okay? We use Q1. The median of all of the data is called the median. The median of the upper half of the data is our third quartile. And we use Q3 to represent that. And then the largest piece of data we call the maximum. All right, so what does this mean? Well, here's a box plot, okay? And the way this works is this line here, okay? This right here, hold on, represents the beginning of our data. So whatever this is, that is our min, okay? Where that line stops, it stops at whatever number is the minimum data. So in this case, we could guess and say it's 2, right? So this would be our min, our minimum number. Our quartile 1, or here we go. So then it would logically make sense that where this whisker ends is our maximum number, okay? So this is going to be our max. And in this case, we can guess and say it's, if we were to go straight down, 19. Okay? 2 and 19. Our median is going to be this line here. And in this case, our median is 15. Our Q1 is going to be this line here. This is going to be our quartile 1. And this line here, oops, kind of close together. Let me see if I can. This line here is our quartile 3. So we have the minimum number and the maximum number. We have the median, or the middle number if you were to order all the data between least to greatest. And then the quartile 1 is just the median again, the middle number, the middle data between the minimum and the median for all the data. And the quartile 3 is going to be the median or middle number between the halfway point, the median, and the maximum number. And we use box plots to represent data because, like in the warm-up, they gave us all those dots. Well, if we had a ton of data, looking at it with all those dots, we'd have to do all the calculations to figure out the mean, the median, what have you. Box and whisker plots are used, are a type of graph used so that you could look at it and instantly know without having to calculate what the data is. So in this case, I can just look at this graph and know, okay, well, the smallest number in the data was 2. The largest number was 19. The middle number was 15. Between the first and the middle number, you know, the halfway point or the median for that we could say is about, I don't know, if it was right here, 12. And we could do the same thing for getting an idea of what the quartile 3 would be. And, you know, if it was right here, we could say something like 17. So it just gives you a snapshot of what all the data is, right? So use the data below to create a 5-number summary and sketch a box plot. So the following data represents the number of animal crackers in a snack size box. So we have the data. The first thing we should do is order it from least to greatest. So we're going to have 34, 45, right? 34, 45. We have 47, 48, 48, 49, and then 50. All right. I like to cross out the numbers to make sure I got them all. Now, it's really easy when you put them in the order from least to greatest to get some of this information. For instance, the minimum we now know is 34, right? And the maximum, we can just look at this and say it's 50. For the median, we need to find the middle number, so we're going to cross these out. And we see that 48 is the median. Now, if I want the median, or the quartile 1 and the quartile 3, those are going to be the medians for the first half and second half. So if I have 34, 45, 47, and 48, okay, so 34, 35, 47, and 48. Okay, so this here was our median. Okay, so think of it as a line goes here. So maybe this will be better. You put a line here and you put a line here. You put a line on either side of the median. And then you want to get the medians of the other side. So if I were to now find the median of the first half of the data, I can see it's 45. Okay, so 45 is going to be our quartile 1. Now on the other side of the data point, we have, here's my 48, and then we have another 48, 49, and 50. This was our first median, right? So I'm going to draw my line, and we're just looking at the upper quartile, right? Quartile 3. Well, we can see that 49 is going to be our median for the upper half. Here, I'll put a pink. Okay. So now when we draw our box plot, I know that 34, let me go ahead and erase some of this. I know that 34 is my min, so I'm going to put a little whisker here at 34. I know 45 is my quartile 1. 48, I'm going to say is about here. 49 is my quartile 3, and 50 is my max. Now we call these box and whisker plots because your max and your min are always whiskers, right? And then your quartile 1, median, and quartile 3, we actually connect those boxes. And then you end up with this. So your box is your quartile 1 through quartile 3, right? It's going to look like, let me see, what can I use? This is going to be our box, right? We're going to have lines separating them. And then our whiskers are going to be the max and the min. So here's my min, here's my Q1, here's my median, here's my Q3, and here's my max. Okay? Try to do number 2. Pause the video, and then when you're ready to check your answers, restart the video and see if you got the data correctly and drew your box and whisker plot correctly. Pause the video now. Welcome back. Okay, so we have this set of data. If you were to put it from least to greatest, you would see that you have 8 first, okay, and then you have, oops, you don't have 8 first, you have 7 first, 8, and then the next one's going to be 2 9s, and then 1 10, 2 11s, 112, 2 15s, a 16, and then a 19. Oops, and there's a 14 right here. Gotta be careful with these little guys. Okay, so then we can see that 7 is the min and 19 is the max. If we start going through these and we go, okay, what's the middle number? You'll see that if we just start crossing these out, the median is 11. Okay, so this is our median. So now I'm going to find, because remember, you draw a line on either side of your median to get your quartile 1 and quartile 3. So your quartile 3 will be all the data on this side. That's going to be your your Q1. And then your quartile 3, you're going to pull from all the data on this side. And you're just finding the median again. Okay? You're just finding the median again. So for quartile 1, if I were to start crossing out data, here's my first, second, we have 2 9s. We could take the mean of 2 9s. You would get 9 plus 9 equals 18. 18 divided by 2 is just going to give you 9. So there's my quartile 1. For my quartile 3, once again, I'm going to try to find that middle number. And I see that it's 15. Right? Because 15 plus 15 is, oops, equal to 30. 30 divided by 2 is 15. All right. Now that we have our 5 data points, we can draw our box and whisker plots. Now remember, our box is going to be the Q1, median, and Q3, and we're going to separate them with lines, and our whiskers is going to be the min and the max. So if our Q1 is 9, I'm going to say 9's about here. Our median's 11, so I'm going to say our median's about there, and our Q3 is 15, so 15 is there. And that's going to make up our box. And then our max is 19, so I'm going to say 19's about here, and that's going to be our first whisker. And the minimum 7, I'm going to guess that that's about there, and there's our second whisker. And that's the box and whisker plot for number 2. Go ahead and pat yourself on the back if you did it correctly. Now, here is your Module 5 Spiral homework number 7. Remember, it's a little bit of everything since the beginning of the year to help you practice. But more importantly, now you're going to do the box and whisker plot temperature project. You're going to choose 2 different cities from anywhere in the world. The cities do not have to be located in the same country, so you could choose Sacramento and Morocco if you wanted to. Or you could choose Paris, France, and Guadalajara, Mexico. Okay? It's 2 cities anywhere in the world. You're going to look up their average temperatures in degrees Fahrenheit for every month of the year. Then create a rough draft of a box plot, of a box and whisker plots for each city's average temperature for the year. Record your information below. Once you've done your rough draft on this paper, get it checked by me, Mrs. Rodrigues, so you can get approval to do the final draft of your project. So this is what we're looking at. There's a space to put city 1 and city 2. So for example, you could do Paris, right? France, and the second city you could do could be anything. It could be San Francisco. Then you're going to look up the average temperature for January in Paris, February in Paris, March in Paris, April in Paris, May for the whole year. And then you're going to do the same thing for San Francisco. Once that's done, you're going to create one box plot for this data for Paris. Oops. Okay, so this is going to be your first box plot. This is going to be your second box plot, San Francisco. So remember, for Paris, you're going to have to find the min, the quartile 1, the median, the quartile 3, and the max after you have all of your data points. For San Francisco, same thing. You're going to have to find the minimum, the quartile 1, the median, and the quartile 3, and the max for San Francisco after you have the data for the whole year. Go ahead and draw your rough drafts on the bottom, and you also have a second piece of paper that you can use to do your calculations and draw your box plots. When you are done, this is just your rough draft, come see me and I will give you your larger, nicer project paper to do your final project on, right? Because you're going to be graded on your calculations, your accuracy, did you do it correctly, but also your presentation. So you're going to want to do a nice job making your poster. All right, and remember, as always, if you have any questions, need help, need clarification, if there's anything you need, feel free to ask me during class, after class, or make an appointment to see me during office hours. I hope you have a great day. Bye.